Today we shall present one more example about the Euler-Lagrange equation. Namely, using the implicit form of the Euler's equation, this form, find the minimum of the functional of this very functional in the space C2 0 on 0 1 interval of all functions twice continuously differentiable which vanish at the ends of the interval 0 1. This example is very similar to the previous one, where 4 stands for this function sigma of x and sin pi x stands for the given function f of x. We note that generating function for this very functional g of x qr equals r square stands for derivative square, 4q square stands for u square, and minus 2 pi x q stands for that coefficient 2 sin pi x u. In order to get the Euler's equation, we have to evaluate the partial derivative and the total derivative for this generating function. So, good. We evaluate the partial derivative with respect to q. We have here, yeah. So evidently it is derivative. This derivative of r squared with respect to q is 0. 2 times 4, which is 8q, minus 2 sin pi x, minus 2 sin pi x, because derivative of q with respect to q is 1. So we have then the total derivative as it is in the previous example, given by the formula, which is elementary differentiation of composed function of 3 arguments with respect to x. So, to get that expression in the Euler equation on the left side, we put instead of the partial derivative the expression we have already done. So we put this here. This coefficient second derivative q with respect to r of this function evidently is 2, because first derivative with respect to r is 2r, and the second will be the constant 2. This is independent of r, it will be 0. So minus this minus put that 2 we have here instead of that second derivative 2, and we have the second derivative of u as in the formula. The mixed derivative with respect to qr is 0, because if we differentiate this first with respect to r, we have 2r. If we differentiate 2r with respect to q is 0. The same, this second derivative, mixed derivative is 0 for the same reason. So we remain with that expression, Euler's expression in the case of that functional, and this is equal to 0. So we have Euler's equation. This Euler equation, so we can simplify by 2 and move sign on other side. Then we have the Euler's equation as the necessary condition for existence of the minimum. To evaluate the minimum of the functional, we have to solve this Euler equation with the homogeneous boundary value conditions. So one can solve the Euler's equation with the homogeneous condition using a pen and paper to get more experience in calculations. Here we shall solve this boundary value problem using Mathematica system for doing mathematics. Let us go to the Mathematica system. We are here, so now we can use the Mathematica command d solve, which is in the library of the system. Then we have what to solve. We solve the Euler's equation, that is minus second derivative of x plus 4u of x equals sine pi x. This is the Euler's equation. Under the conditions, we have to list that Euler condition in the command u of 0 equals 0. Then u of 1 equals 0 again. Close the curly brace, and we have to solve it with respect to unknown function u of x and the variable x. So we have this command. Let us enlarge the command to have better appearance, to see better. Okay, we have it. Okay, let us move that command on that right to see that. Now to get the solution, we execute the command pressing Shift Enter. Okay, and we have the solution here, sine pi x over, in fact, pi square plus 4, because pi plus 2i times pi minus 2i is pi square plus 4, evidently. So we have the solution. Let us come back to the original document. We go to the original document. Yeah, we are here, and we are here. So we have executed that mathematical command, and we have obtained that solution in a second. So we have it. Now to evaluate the minimum, we find the value of the functional f of u at this very solution f u of x sine pi x over pi square plus 4. So then again we can use Mathematica. We shall do it later, but now what kind of commands we have to enter? We have to execute command. We have to define the function u as it is with sine pi x over pi square plus 4, and we write that integrate the expression first derivative square plus u of x square minus 2 sine pi x u of x. We use old version of the Mathematica. One can use a symbol of integration instead, and as a result of that execution of this command, we get minimum of the very functional equals minus 1 over 2 pi square plus 4. Let us confirm that result again using the Mathematica system. That is nice to get it in short time, easily. So first fact, as we have said already, we have to define the function u of x with the late argument. The function u of x, what is that? Of course, sine pi x divided by pi square plus 4. Good. So we have typed that function, but let us again enlarge that appearance to see better. Okay, and we have it. Let us put that in that way. Okay, now to get the solution, we have to enter the definition of u to the memory we have there. We confirm that we are right, that this is the function we deal with. So if we press that, we have it. Yeah, we have it. Really, this is the function, the solution of the Euler's equation. Now, to get the value of the functional, we write the command of integration, integrate. What to integrate? Let us move it on the right. Integrate derivative u of x square. This is what we're supposed to integrate, plus 4u of x square again, minus 2 sine pi x, let us make space, pi x, and u of x. This expression we integrate with respect to x in the interval 0, 1. Good. Yeah, let us enlarge it again. Okay, we have it. We have it. Enlarge. So we execute the command. Yeah, that is the value of the mean is a mean of the functional 1 over minus 2 for pi square. Thank you.